Presentation goes along with CSE Activity 112. We introduce the idea of an automaton, which is simply a type of computer that follows pre-programmed instructions. And along the way in this activity, we introduce some important programming concepts like instructions, states, and functions. Computers and humans are similar in that we use inputs to affect how we interact with our environment. For example, here in Oklahoma, if we hear an input, the storm sirens, our response, which is the output, is usually to grab our phones, go outside, and video the tornado. Reasonable inputs and outputs. Computers interact with their environment based on inputs also. Computers may have cameras, keyboards, GPSs, other sensors, and outputs may be display screens or speakers, or maybe just a message that it sends across the network. Lightbot really has no inputs other than the commands that you give it. These commands cause Lightbot to change its state. One part of Lightbot's state is its location on the XY grid. The state of a computer can be much more complex than just two variables. Those of you that had DE learned about state machines, and if you're in DE now, you'll learn about it later on in the year. We're not going to explore state and state machines nearly as thoroughly as we do in digital electronics. But state is a concept shared between several fields of engineering, including electrical engineering and computer science. For now, just knowing that state is how we refer to the current conditions of a computer or a program is enough. So in this example, the Lightbot is standing at 3, 2, which means that its state could be described as x equals 3, y is 2. Now, direction is an important part of Lightbot's state also. So we could describe Lightbot as having the state variables x, y, and direction. And in this example, Lightbot's state is 3, 2, 0 degrees. In this picture, Lightbot's state is 7, 8, 270 degrees. If you count the squares, you'll see that Lightbot is standing on square 7, 8 and facing the square 7, 7. Engineers use state diagrams to show how inputs cause a program or a computer to change state. For example, if Lightbot is at 7, 8, 270 and receives a jump command, it returns to the same state. But a forward command results in a new state of 7, 7, 270. So the different commands can either cause a change in state or just cause Lightbot to do something. We won't spend any more time with state diagrams. It's just something that you need to see and recognize as a way of representing how a computer or a program responds to its inputs. Lightbot is a simple example of a class of computer called a Turing machine. We'll learn more about Turing and his work in the area of cybersecurity later on in the year.